Hi, welcome to another lesson at Edu Solutions Institute. We will be doing physics at CSEC level. Now, today's lesson, we'll be continuing with forces, and specifically we'll be looking at the elastic force. So last week lesson, we focused on weight, which is a force due to gravitational pull, and now we're going to look at the elastic force. Now, the elastic force has to do with the force that's required to keep an object in its natural state. So as we can see here, this spring is bouncing up and down. Now, the reason why it's moving up and down is when it's pulled down, there is an elastic force that's pulling it back up. And when it's up, there is a force of gravity pulling it down, right? So if we stop this object from moving, right, and we take off the mass from the object, it goes to its natural state. Now, this is where we have just a natural spring. Now, if we add a weight to the object, notice that it now occupies a different position. It's now stretched. So stretching now will include their creating an elastic force that when we take the object off, the spring returns to its natural position. And this is what the elastic force is. Now, elastic force is incorporated in a special law known as Hooke's law. And Hooke's law tells us that if we change the mass or the weight of an object on a spring, right, then the extension will also change. As we can see here, if we increase the mass, which is the weight of the object, the extension of the spring gets bigger and bigger. So from 300 grams, which we can convert to the newtons by finding the weight, we see that if we reduce that mass, which is the reducing the weight, the extension gets smaller. So therefore, Hooke's law tells us that the force applied to any object is proportional to the extension it produces, and that's only provided if it does not exceed the elastic limit. Now, you might ask, so what is the elastic limit? The elastic limit is the point where if you continue to add different masses, it reaches a point that if you exceed that extension point, the object will not return to its original position when it is removed from the spring or the elastic object. So that's what the elastic limit is. So once we're in that range of elasticity, then once you remove the mass from it, it will return to its original position. If we exceed that point, then if we continue to add mass and remove the mass, the object will not return to its original size or shape. Right? Now, to do the experiment for Hooke's law is quite easy. Right? All it requires is to have a stand to attach a spring to, and we have different masses. So if we use this simulation here, and we start off with the smallest mass of 50 grams. So therefore, it would be 0.05 kilograms. And if we find the weight, it's going to be 0.5 newtons. So this 0.5 newtons, if we add to this spring, which at this point has a specific length, right? If we take the ruler, measure from the top coil to the bottom coil here of the spring, we get 45 centimeters. Now, if we add that 50 grams mass to it, we stop it from oscillating, it now occupies a new length of 54 centimeters. So what we see here is that it moved from 45 to 54 centimeters. So there is an extension of 54 minus 45, which would be 9 centimeters, right? Now, what if we change the mass and we go up to, let's say, 100, right? Now, the 100 would be, we take off the mass, it's the spring is still at 45 centimeters. We add our 100 grams, stop it from oscillating, and it now occupies a 61 centimeters. So now with 100 grams, it moved from 45 to 61. So therefore, it will be 61 minus 45 to give the extension, right? And we can continue as that till we get at least 6 values that we'll be able to plot a graph with. So as we can see here, based on this simulation, that if we increase the mass added to a spring, then the extension will also increase. And that gives the principle at which Hooke's law operates, at which elastic forces operate, right? And that from that, we can get the formula for Hooke's law that says that the force is equal to the spring constant K times the extension E. So the force would be in F, so capital F equals to a common K times E, which is for extension, right? So therefore, we see that between force and extension, they are directly proportional. So if the force increases, the extension will increase. And finally, what exactly is the spring constant? Now, the spring constant is a constant number for a specific spring type. And what this tells us is that it's how stiff the spring is, meaning how much force is needed to cause the spring to extend. So therefore, if it has a high spring constant, then that means it needs a very high force in order for it to start extending. And also, if it has a low spring constant, it requires a small force to create an extension, right? So therefore, that principle is also used to know what type of spring, what type of elastic object we can use for different situations. So like for the suspension on cars, we will need one that requires a very high, sometimes based on the type of car, and then some will be very low depending on the type of vehicle that it's going to be on, right? So this is our lesson for today, where we looked at Hooke's law, more specifically the relationship between extension and the force applied to an elastic object. Hope you understand, and I'll see you next week where we continue to learn about the CSEC physics syllabus. Thank you.